Hello and welcome to this video tutorial, second tutorial in a little series where I'm showing you how to use Perlin Noise to generate. Let's get this starter going, this timer going. Sorry, down in the bottom. So we're adding Perlin Noise to a plane, and I'm showing you how to do that. And we're using Perlin Noise, if I haven't said that already. Right. So where are we? Last video, we've created this tile, which is just a plane, and it's got loads of vertices all over it, and we're just applying Perlin Noise to lift up those vertices in a for loop. So if I pause it, all we've got in our scene is this one plane. I think since last video, I've just added a skybox, and I've added like 3 balls that fall down, and just to show off the Perlin Noise moving. And also I've added, I think a way to press the space bar, and yes, we can stop the Perlin Noise, or rather, what we're doing to have this, it looks like a flag, to have this kind of like wavy flag-like behavior. All I'm doing is kind of like cycling through the Perlin Noise on the z-axis. Yeah, that was the last thing we did. So if that doesn't make sense, go to the previous video where I explain how to use Perlin Noise, what it is, how to use a seed to, for instance, like this. If you liked a bit of scenery, a bit of landscape like that, you could save this seed and then return to it, like you might do in No Man's Craft or Minecraft. No Man's Craft? No Man's Sky? Or Minecraft. No Man's Minecraft. There we go. Right. So let's stop this and go to the code. So what I want to do is create several of these. One way I could do this is just Command D would duplicate it, and then if I run it again, hopefully I'll have 2 of these. Yeah, you can see there's another one beside. If I just pause it, we can see that a little better. So the Perlin Noise is being applied. Now, what would happen is if I just lined them up precisely, and started it again actually, if I align them properly, you would get continuous terrain, and so that's a nice move. Continuous terrain. So that's what we're going to do here. So let's delete this random example tile. So we want to create an empty game object, and so all an empty game object is a transform, and we're going to call that our terrain manager. There we go. Terrain manager. And what we want to do is create a new script and attach it to that terrain manager. So we call this the terrain brain. Terrain brain. Okay, and so we don't forget, there's our terrain manager. Let's attach that now. So you can just drag it underneath the add component, and that will allow you to attach it. So if we open up terrain brain, we'll have a nice fresh programming canvas. Here we go. So we want to have some variables like how many tiles are we going to have. So we could think about this like a big grid. We could think about the x dimension and the z dimension. So what we could say is public int x tiles equals, and let's put a default in of 4. Let's not get ahead of ourselves. So we want 4 tiles along, and then you can say how many tiles you would like. We'll call those z tiles 4. Okay, so we'd have a grid 4 times 4, 16 tiles, if this were the case. And what we want to do is use a prefab. We want to save this as a prefab, this tile, this little ground object. We want to be able to kind of have the code instantiate, create these ready-made little ground tiles in a grid shape. So to make a prefab, all you have to do is select the object that you've made and then drag it into your assets. Now this, Unity will will use as a prefab. And that means prefabricated, pre-made object that your code can actually refer to. So we'll go back to the code and I'll show you how to refer to stuff. So we want, again, a public object. I'm making these variables public so that we can fiddle around with them in the inspector as and when we like. So we want a public game object, and we'll call this our tile prefab. You can call that whatever you like, and I'm just going to set it to null to begin with. Okay, so if we go to Unity and we click our terrain manager, which is just an empty game object, let's just put that at the center of the world. It shouldn't make a difference. And so there, our terrain brain has now got our xtiles variable, which is an integer. I've said it's an integer, not a floating point, not a float variable, because we don't want like 4.2 tiles. We'd always have a whole number. So that's why we've gone for integers. And then tile prefab, and we've got none in there at the moment. So what you can now do, now that you've made your prefab, we can drag this into there, because this variable is a game object. So it is expecting you to put an object inside of it. So we've done that. Okay, so now all we need to do is, referring to this prefab, we need to instantiate it in a grid. So we're going to have to use some kind of for loop, I'm anticipating. So let's create a function, and we'll call it lay out the terrain. There we go. Okay, so let's try a for loop. Let's just try and start coding before even thinking about it. Let's say I equals, well actually let's refer to x and z. Int x equals 0 while x is less than x tiles number, x increments, and then we're going to have to nest the loop. So we're going to go through every single column and then every single row. Okay. For int z equals 0 while z is less than z tiles number z plus plus. Okay, and so basically in here, what are we doing? We want to instantiate our prefab, so that tile, and we've already done the programming. As soon as we, for how the terrain will work, as soon as we place that down in the world, our code will bring up our code. The hills are alive. So our code, when it generates the Perlin hills, it will use wherever the transform position is. So wherever that plane has been put, compared to whether, and in addition to where each individual vertex is relative to its parent transform, it will work out the Perlin noise for us. So we can just throw those things out there, and all the maths will work, will take care of things. So we just want to instantiate. So to do that, to instantiate, you write game object instantiate, and then you place in here the object that you want to instantiate. So we've stored that in the variable tile prefab, and then you can, this function instantiate, which belongs to the game object class, it's overloaded, so we can add different kinds of parameters. You'll notice here it's asking for the transform of the parent. You don't have to set the transform of the parent. If you put in a position, then it will place this new object in that position. So we want to know where our terrain manager is going to like have a point of origin, and it's going to build a grid according to that point of origin. So we'll say that point of origin is like the top left of our grid of terrain tiles. So let's create this. I've already had 10 minutes. I don't think I'm going to make it. So let's say we need a vector position. I guess we need a vector object. So public vector3. We want to call this terrain origin. I'll just call it terrain TO. No, I should call it something longer. I can feel a sneeze coming. Oh no. Excuse me. Excuse me. Am I allowed 10 more minutes because I sneezed? Yes. Right. New vector-free terrain object. There we go. Oh, we should give it some defaults. So by default, we're going to say 0, 0, 0, something like this. Or it's fashionable to put things, I don't know, 20? 20 and minus 20, something like that. 20 minus 20. So x minus 20, 0 for y, and 20 over there on the z direction. So we've got the origin. So let's say we want terrain O dot terrain O. We need to put an entire position in here, so we kind of have to work out this position beforehand. So we call it my position or my pos, and rotation, we don't want to add any rotation to it. So if you want neutral rotation, it's quaternion dot identity. The identity just means the original point of rotation. So you've added no rotation to something, it's quaternion identity. Right, so we need to make my pos. So this is going to be a transform. No, it's not. It's going to be a vector 3 as well. So vector 3, my pos. Okay, so we want to say up here, my pos x component equals the terrain origin x position plus x times, now x was the number of tiles, so as we go along the columns, or along the rows I suppose, along the rows, we want to multiply our position by the size of each tile. So we're talking about one of these planes. Now its scale is 1, but actually a default tile will be 10 units across. So you want to say 10 times whatever number the user puts into here. So then if they wanted smaller tiles, like 0.5, I've just realized I'm looking at the terrain manager, not the tile. So if I actually click the right object, so at the moment it's 4 by 4. And so we want the user to be able to change these as much as they like, and our code still to work. So we've got to have some dynamic code. So we're going to say times 10f times, or multiplied by, our prefabs, terrain, what do we call it, tile, if I put in tile prefabs transform scale, and you want to refer to the world scale, so lossy scale dot x, we're talking about its x dimension. So all we're doing here is calculating where the x position of our tile is going to be. So if we're talking about the first tile in our grid, let's imagine that's the origin, so the top left of where the terrain manager will create things. So we might say we want, terrain brain's not working at the moment. Oh, it's because we haven't finished something. What haven't we finished? Let me just debug this. Assets, terrain body, my pos, use of unsigned local variable. Why can't that use that there? Oh. what we could do is give this a position, I guess. Let's just say vector 3, 0. Oh, there's the time. So we've had 15 minutes. Let me put another timer on. How do I start this again? Oh no. Okay, I'll abandon the timer. Right. Can I just put vector 3, 0 in there? Will that be fine? So all I'm doing is instantiating this this tile at vector 3, 0, which means 0, 0, 0, right in the middle of the map. And then we could translate it. So we want to say game object new tile, or new t, equals that, and then we can get hold of our new tile, and we can refer to the transform and then use the translate function, and we first want to move it in the x position. So vector 3 dot right times my pos dot x. There we go. So in fact, my pos could just be a float. We could just make two floats. Anyway, right. I went over that rather quickly, in part because I was trying to iron out this bug. Will that disappear? Yes, okay. So now I can do what I was trying to do. So the terrain manager, there we go. The terrain origin we've set as x in the minus direction, 0 for y, and 20 for z. So maybe somewhere over here. And then what we're going to do is then say tile, start new tile, we'll instantiate you at 0, 0, 0, and then we're going to translate you to your correct position on the x, and then we're going to translate you correct position on the z, like that. And translation just means slide it along one of these axes, and we're calculating that position by saying find the terrain origin. That's the terrain manager's top left. So start there, and then add on what column you're in, times 10, because that's how big a plane will be, times the actual kind of scale of that tile, so that when we add the next one, it will be nice and neatly in the right place. And then we're going to add all the rest of them. Okay, so we've done everything for the x. Let's now do it for the z. And oh, we haven't translated it in the z position. So my position z, I should leave a space there so that doesn't look too complicated. So where is my z position? My z position will equal the origin's z position plus what row we're in. Or is that column? can't work that out. That's a column, isn't it? No, that's a column. So which row we're in, times 10 times the scale of the tile on the z dimension, and then we're instantiating the tile, and I'm just storing that tile in a little temporary variable called new t. So it's a game object, just like the prefab is a game object. So storing it in that variable so that we can now get hold of the new tile and move it around. So first we're translating it on the vector 3 dot right axis. That just means the x-axis. So on the x-axis, we're moving you to my position dot x. There we go, which we've worked out up here. So we're now going to do exactly the same thing for my position dot y. Surely there is a quicker way to do this. I'm sure I could just add this into its position and just say that your position is this thing, but I don't know. The way to do that escaped me for whatever reason. Transform dot translate So now we want to go in the vector3 dot z position, which is called forward, times my position dot z. There we go. Right, I believe that's pretty much finished. I think that's actually finished there. So we should kind of call this function. So when we start, what I should also do is let's just disable our little ground. I'll just save scenes, save project, so everything's intact. So there's nothing in our scene except these 3 balls, and hopefully the terrain manager will kick in and create us 16 tiles. So here we go. If we get some bugs, that'll be a similar thing to what you might encounter. Right. This looks like it's worked straight away. That's very unusual. So let's pause it and see what we've got. Okay, there's definitely some bugs. You can see that the tiles are not matching perfectly. Oh, we can see at the seams there's some difference. So I'm not somehow aligning them correctly. Oh, that's probably to do with the seed and the point at which they all need to have the same seed. So maybe I'm just out of sync for the seed. I'm not sure. But there we go. We've got 4x4, and this is the next step in creating truly procedural terrain. So our next step will be to add a rigid body in here and like walk around, a first-person controller, for example. Or maybe we should make a moon buggy or a terrain buggy with massive wheels. I'll do that ready for the next video. I'll get that ready. And what I'll do off camera is sort out this bug, because that will probably take me ages to work out on screen. Okay, but I will tell you how to fix that. So there we go. We've got the next step done. Thanks for watching. See you in the next video, maybe. Where's the stop button?